The last of our 4 transformations we're going to look at are dilations. So far we've talked about translations, reflections, rotations, and now we're going to look at dilation. When you go to the eye doctor, they dilate your eyes. They make your pupils bigger so they can see inside them. So a dilation is a change in the size of something. Okay, at the top of our notes, we have a dilation is a transformation in which a figure is made larger or smaller with respect to a fixed point called the center of dilation. So a dilation can make things larger or smaller. The ratio of the side lengths of an image to the corresponding side lengths of the pre-image is the scale factor of the dilation. So our sides of our figures are proportional. They have a common ratio. And the image to the pre-image, that ratio is the scale factor of the dilation. For dilations, the pre-image or the original image and its image are similar. All of our other transformations, our translations, rotations, and reflections, were congruent. They were the same size. But in a dilation, the image and the original image, are similar. So the original figure and its new shape are similar figures. Now, when we have a point, this is called the center of dilation. Label that, please. The center of dilation is where it dilates from, so where it gets bigger or smaller from. On a coordinate plane, this will typically be the origin. Now, we can get bigger with our dilation. That means that we have an increase or a scale factor bigger than 1. It expands the figure. So expand means to get bigger. You can also have a dilation that shrinks your scale factor. You could have a dilation that makes it smaller. And if we're shrinking, it's just called a shrink. So we have something that can expand or get bigger, or we can shrink the figure and get smaller. Now, remember in math, the word dilate means to shrink or expand. Shrink means get smaller, expand means get bigger. All right, the next part are dilations. When you dilate a figure, the scale factor tells you by how much you need to expand or shrink this. Sometimes we use the value k, sometimes we use the value m. For these notes, we're going to use k. It's just the letter that we're using for our dilation or our scale factor. When the value of k, or when your value for your dilation is greater than 1, then the scale factors are greater than 1. So when your scale factor is greater than 1, your figure expands. That means that it gets bigger. When your value of k is less than 1, then your figure shrinks, and that means that it gets smaller. So values for your scale factor bigger than 1 make your shape expand, and if it's smaller than 1, it shrinks. When you dilate a figure in the coordinate plane with respect to the origin, you multiply the coordinates of each vertex by the scale factor k. So for instance, if we had x and y for our coordinates, and we wanted to make them bigger or smaller and dilate them, we would multiply the x and the y value in our coordinates by the same number. So this might be a number 7, value of k might be 7, it might be 3, it might be 1/3, but k is your scale factor telling you how much bigger or smaller your shape gets. So let's look at some examples. We're going to look at example 1 first. We're going to dilate a figure by a scale factor greater than 1. This means that we're going to expand our figure. It's going to get bigger. Now, the graph has the image on it, or the pre-image on it. We're going to dilate this using a scale factor of 2 and 0, 0 is going to be our center of dilation. For us, most of the time, our center of dilation is going to be at the origin. It will not always be that way, but for you in 8th grade, your center of dilation will typically be 0, 0. The steps to do this. We want to identify and record each point in the pre-image. We're going to identify the scale factor and decide if it's expanding or shrinking. We're going to multiply the coordinates by the scale factor and record the new coordinates, and then we're going to plot the new points and label the image in prime notation. So our scale factor is a scale factor of 2. That means this is getting bigger. Our scale factor is bigger than 1, so we're going to make this shape twice as big. Now, we have x and y, so our rule is going to be 2 times x and 2 times y. In this example, the point T is at 1, 1, the point D is at -1, -1, and the point S is at 1, -1. We're going to multiply the x value by 2 and the y value by 2. So our image for T, our image of T would be, well, 2 times 1 is 2, and 2 times 1 is 2. So point T is going to move to 2, 2, put a dot at 2, 2, and label it T prime. Our point D is at -1, -1. If we multiply the x value by 2, that gives us -2. If we multiply the y value by 2, that gives us a -2. So our value for D is -2, -2. We're going to put the image of D on the graph. And then the last one we have is 1, -1, point S. If we find our image, well, 2 times 1 is 2. -1 times 2 is -2. So this ordered pair is going to be at 2, -2, and that is the image of S. We connect these points for our new triangle, and we see that this has gotten twice as big. Our triangle is twice the size of the original one. Our original triangle had a length or a base of 2 and a height of 2. Now our base has a distance of 4 and a height of 4. So not only did the points get twice as big, but the length of each side is twice as long. Now, for example 2, we're going to dilate the figure with a scale factor less than 1. That means this is going to be a shrink. If our scale factor is less than 1, we are shrinking. And the instructions tell us to graph a dilation with a scale factor of 0.5. We know that's less than 1, and 0, 0 is our center of dilation. So this time, we're going to identify and record our points, find the scale factor, and multiply each of the points by that scale factor. And we're going to plot the new points and write it in image in our prime notation. So this time our scale factor is 1/2 or 0.5. That means we're going to multiply each x value by 0.5 and each y value by 0.5 or by 1/2. Our ordered pairs, point N is at -1, 4. Point J is at 3, 1. Point M is at 0, -3. And point Z is at -2, 0. Now, to find our image for each of these, we're going to multiply the x value by half and the y value by half. So here we go with our image. Point N, well, half of -1 is -1/2. So we're going to have -0.5 for the x value. And then for the y value, well, half of 4 is 2, or 4 times 1/2 is 2. So we're going to go to -0.5 and 2. That means we go to the left halfway and up 2. You can see that this is twice as close to the origin. It's shrinking, it's getting smaller. Now point J is at 3, 1, so half of 3 is 1.5. Half of 1 is half. So we're going to go to, oh, let me label the last one. That was N prime. Labeling point J, we're going to go over to 1.5 and up to half. Here's point J. It is getting closer to the origin. It's shrinking and making our shape smaller. Half of 0 for point M is 0, and half of -3 is -1/2. So we're going to go over, or we're going to stay on the origin, then we're going to go down to 1 and 1/2. This is point M, or the image of point M. And then point Z, well, half of -2 is -1, and half of 0 is 0. So we're going to go left 1, and we're not going to go up or down at all. This is point Z. Now, all of these we multiplied by 0.5, or 1/2. So we took all of our x and all of our y values and cut them in half, or multiplied by 0.5. Now, we're going to connect each of these coordinates for points n prime, j prime, m prime, and z prime. And you can see that our shape, our quadrilateral, shrank, and it's each distance is half the size. So the preimage shrinks and our center of dilation is in the middle. That smaller one with all of our prime notation is the image of this. We're going to work on scale factors quite a bit next week. Make sure you have all of this taken care of before we start on Monday.